Hello students, welcome to the concept modulation. In the last video I explained about the block diagram of communication system. In that communication system I told that to send the information from transmitter to the receiver which are physically separated by logic distances. What is the concept? Actually the message signal or the information signal is of very low strength. When we send that signal directly to the receiver, then after traveling some distance it dies out. That is the reason you have to take the help of another high strengthened signal called carrier, and carrier will carry this message and it won't die out even after traveling longer distances. Okay, so that is the concept of modulation. Now I'll define the modulation. Modulation is the process by which some characteristic of one signal is varied in accordance with the instantaneous value of another signal called modulating signal. Okay, this is the general definition of modulation. Coming to our communication, yes, it is the process by which some characteristic of one signal. What is this one signal? Carrier. Carrier is varied in accordance with the instantaneous value of another signal. What is that? Another signal. This is nothing but our information signal or message signal. Okay. That message signal is called modulating signal. This is the definition of modulation. Simply, we are changing the characteristics of carrier with respect to the message. The message signal is called modulating signal. Fine. And this carrier is of high frequency. Is this message signal is nothing but our information, and this is also called baseband signal. Okay. After the modulation, you'll get one signal that is called after modulation. Means after you change the characteristics of the carrier with respect to the message, I'll get one signal. That signal is called modulated signal. Okay. Yes, this message signal or information or baseband signal is called modulating signal. We have types of modulation. The two types of modulations are continuous wave modulation, that is CW modulation, and the second one pulse modulation. Okay. Yes, in the continuous wave modulation, the carrier is continuous and it is a sinusoidal wave. Okay. And under CW modulation, we have three types: AM amplitude modulation, FM frequency modulation, and PM phase modulation. These two combinedly all called angle modulation techniques. Okay. So what is AM amplitude modulation? Amplitude of the carrier is varied in accordance with the message signal. FM frequency of the carrier is varied in accordance with the message signal, and PM phase of the carrier is varied in accordance with the message signal. Okay. In future videos, we'll see this AM, FM, PM in detail. These two combinedly are called angle modulation. Here in the pulse modulation concept, the carrier is pulse type or pulse type carrier. Okay, you know the pulse type carrier? The pulse type carrier is like this. You know the sinusoidal, it is like this. Okay. Yes, pulse type carrier. This pulse modulation may be analog or digital. Okay. If it is analog pulse modulation, we have PAM, PPM, PDM. If digital, Yes, we have PCM. Yes, if the pulse modulation is of analog type pulse modulation, there exist three modulation techniques: pulse amplitude modulation, pulse position modulation, and pulse duration modulation. If it is a digital, the modulation technique is pulse code modulation. Okay. These are different types of modulation. Now we'll see what is the need of modulation. That is the very, very important thing. Okay, the concept is need for modulation or benefits of modulation. What is the concept? Need for modulation concept is why we are going for modulation. Why we are not able to transmit directly the message signal. Why you are taking the help of carrier and why you are changing the characteristics of the carrier. That is the concept of need for modulation. What happens if you send the message signal directly to the receiver? Okay. What I explained, if you send it directly to the receiver, as the signal strength is less, after traveling some distance, its amplitude gets decreased and it dies out. Okay, the same concept can be explained under this concept need for modulation in different way. The first point under need for modulation is practicality of antenna. We know when the channel is free space, to send the signal from transmitter to receiver, we have to use antennas. At the transmitter end, we have to connect one transmitting antenna, and at the start of receiver, you must have one receiving antenna. And for efficient transmission and receiving, the practical length of the antenna must be quarter of the wavelength of the wave radiated by the antenna. Means, length of the antenna L is equal to lambda by 4. As I said, for efficient transmission and receiving, the length of the antenna must be quarter of the wavelength of the wave radiated by the transmitting antenna. Okay. And we know lambda is equal to C by F. So, it is C by 4F. Now, consider the case AM broadcasting. We are broadcasting, yes, audio signal, means we are sending audio signal of 5 kHz frequency. What will happen if you try to send the signal directly to the receiver? Let us see. See here we are saying broadcasting concept. Broadcasting means sending to number of receivers, sending the same signal to the number of receiver. Like satellite. Satellite is sending the signal to so many receivers, so many TVs. Okay, so that is called broadcasting. Another point under broadcasting is in some communication system, you can interchange the transmitter and receiver. Transmitter will send the signal and receiver will receive. And for the second time, receiver will send the signal and transmitter will receive. That is called duplex system. But in the case of broadcasting, we don't have any sending from the receiver. Receiver simply receives the signal and there exists only one transmitter, but we have many number of receivers like TV broadcasting. This is the example for radio broadcasting. Okay. If you want to send the signal of 5 kHz directly, then what is the length of the antenna? The length of the antenna L is equal to C. What is C? Velocity of light, that is 3 into 10 power 8 divided by, that is meter per second, divided by 4 into 5 kHz. Okay. So, what is this? This is 18 kilometers. Imagine this length. Constructing this much length of 15 kilometers antenna and installing the antenna is very difficult. It is impractical. Okay. So, that is the reason we have to go for modulation. Now, yes, if you consider the concept of modulation, use the carrier of 3 MHz to carry this 5 kHz signal. Okay, then this becomes your F. Then if you calculate, your L becomes 3 into 10 power 8 meters per second divided by 4 into 3 into 10 power 6 Hz. Hz means 1 by second, you know. Yes, so 3 gets cancelled. So it is just 25 meters. Okay, yeah, 25 meters is not a big thing. You can construct the antenna and you can install the antenna very easily. Means there exists some practical feasibility to construct this and to install it. Okay, so this is the first and foremost point of the need for modulation. The second point is to remove interference. Take an example of this radio broadcasting. We have many radio stations. All the radio stations are transmitting the signal whose frequency is between 20 Hz to 20 kHz. That is audible range. Fine? Are you understanding? Yes, we have many radio stations. That is the first point. All the radio stations are sending a signal which is audible. What is the audible range, frequency range? 20 Hz to 20 kHz. Now, without using any modulation concept, if all the radio stations are sending the signal with the same frequency, then what will happen? Imagine the situation of the receiver. Receiver will get confused which signal it has to receive, because all the signals are having same frequency. It can't differentiate. The receivers can't differentiate their own signal. So what will happen? There exists interference. So what will happen if there exists interference? Yes, the interference of one signal with another will reduce the strength of the original signal. Okay, and sometimes it may add the noise to the original signal. So at that time, if you go for modulation, take a signal of every station individually and modulate individual signal with a different frequency. Take first station, use different frequency carrier and send it. And take the second station, use another carrier frequency and send it. Use a third station, take another carrier frequency and send it. You are sending the signal with the different frequencies, not with the same frequency as previous. So what will happen? There is no confusion for the receiver, means you are eliminating or you are removing the interference, so that your signal will be protected. There is no reduction in the signal strength. There is no noise in the signal. Okay, so that is the concept of to remove interference. And the third point, to reduce noise. The same concept here explained, we can adopt here also. So what is this reduction of noise or to reduce noise? Yes, see, if the signal strength is very less, then there exists lot of possibility for the addition of noise. And noise is a random signal, we know it. And when there exists many signals surrounding that particular original signal that we want to transmit, if you want to make your original signal strengthened signal, automatically it gets affected by so many surrounding signals. That signal will interrupt that signal and automatically there exists noise in that signal. So to make the signal strengthen, you have to use the high frequency carrier, and now as the frequency of the carrier is very high, it has high strength. Now when that high strength signal is carrying this low strength signal, no noise signal can be interfered. No noise signal can be added to the original signal. Okay, so that is the concept, reduction of noise. So these are all the concept of need for modulation. One is the practicality of antenna. The second one is to remove interference, and the third one is to reduce noise. Okay, so this is the modulation and the type of modulation and need for modulation concept. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.